Right, hi everybody, good evening. This is the equation quiz session. And before you ask, yes, I'm going to be doing more of these. I think the more frequently we have equation revision sessions, the better. Okay, so I will repeat this again, probably every few months or so, just because I think it's worth just keep refreshing our memory cells for all the equations that we have to come across in science. So what I want you to be able to achieve by the end of the session is what I've just said. It is to revise and become more familiar with all of the equations, because there's not only just the physics ones, there's also biology and chemistry as well. Okay, so we will include some of those. I want you to be aware and be more confident with the units. Okay, so people forget those. So we've got a little, for the first round is all about the units. And then we're going to have a few rounds on rearranging equations as well. So we're going to practice a little bit of that. I know for year 11, you're going to get your equations anyway. However, it is worth still being familiar with them and the units and rearranging them. Okay, you can't just go, oh yeah, that's fine, I don't have to revise those. It's still worth just having that little bit of effort just to go, I remember that equation, it's got to be that. So knowing the equations, it helps you answer the questions. Okay, so there's going to be a few rounds. Pen and paper are needed. The sheets that I have used to copy and paste things onto the PowerPoint are these. Bear with, I will just share if it allows me to share. So here we go. So in no particular order at all. You've got a biology sheet, chemistry sheet, it goes on a bit there. Then we have units as well. So that's to help us go over our units. There's a bit more extra bits on there as well. Equations for this is from last year's paper, but it has like everything on there. And then we've got one from Edexcel, so I've used that one as well. Okay, so there's multitude, and to be honest, it doesn't matter if you're combined or separate. It is looking at those equations at the moment, is getting familiar with them. Like when we come to rearranging equations, it doesn't matter if that equation is just for separates. It is the strategies and the principles that you need to practice. Okay, so don't worry if you're combined or separates. It's everything about this will benefit you. Okay, so there are 5 rounds. And if we have time at the end, I've even got some Kahoots. Okay, so that's why you might need your mobile phone. Now, I haven't used Kahoot for a while, so it is all set up. I'm hoping it will work, and I'm hoping we have time for it. For each round, I'm going to give you time, and I'm going to time it on my phone here. Likely to be like a minute or so, something like that, but I'll keep you updated with the time. You will need the sheets, and then just write the number and what your answer is next to it, and then I will go through the answers. Okay, don't need to call out when you're done or anything like that. This is for you to do in your own time. If you don't manage to answer them all in that time, doesn't matter. Or maybe like comment go, maybe you need more time or less time, but I'm going to try and give you about a minute each one. Okay, but the first one, round 1, ding ding, is all about units. Okay, so one of those sheets will really help you, but what you could do is also try and write down the abbreviation and the unit from whatever you can remember. Can just brainstorm, and then those that you struggle with, maybe refer to the sheet. So this is really good, and it does have stuff on here for separates as well as combined. Okay, so I am going to give you a minute for you to brainstorm as many abbreviation or units as you can. Okay, I'm going to start in 3, 2, 1. 1 minute. Off you go. Which ones can you remember? I need my pen. Oh, hang on, late. For anyone arriving late, this is just our first round. And what I'm doing, I'm giving you 1 minute. Well, you've got 30 seconds left now to brainstorm as many of the units or abbreviations as you can remember, and then using the sheet to fill in the missing ones. Okay. Again, here you're gonna easily do the ones that you remember, so that's good. But then you'll identify the ones that you need to revise, basically. We do have only 10 seconds left. What I might do is give you a few, like maybe another 30 seconds, because we've had that late comer. So if you don't mind, I'm going to give you another shall I give you another minute? Because sometimes you might need to write down the answers as well. I'll give you another minute. See which ones you can remember. Have a quick drink. I need to keep my fluids up. Another 30 seconds. Here we go. 15. And then we got 10. 3, 2, 1, and it's going to bleep. Dismiss. Right then. So doesn't matter if you haven't finished them all. That's absolutely fine. Hopefully you've brainstormed the ones you remembered and then gone to the sheet. But the answers, if it lets me click, are all here. Now, these are vital because I see so many mistakes happening, especially for this one. It's when you're using your equations and you have to change your units and stuff like that. Lots of students don't identify that. Oh yes, it's in grams. And should it be kilograms? Mass should always be in kilograms. Okay. The other one, temperature. I know it says Kelvin there, but it's also degrees centigrade. So if you put degrees centigrade, that's absolutely fine. What are the other ones? Length, that was it. Length, it could be also height or distance as well, is always measured in meters. Okay. And there was something over here I like to mention as well. Force. Another common one that people forget is actually a force is weight. Okay, so I always like to mention that one. Trying to think if there was anything else. I don't think there was. Yeah, remember time is always in seconds. Okay, it's not in minutes as well. That's another one that gets mucked up. Okay, so hopefully by the end of that round it is just identified the ones you need to learn, basically ones you need to revise. And obviously you'll get this PowerPoint and you can print this slide off and put it on your wall and you can revise from it. Okay, so that is round 1, units tick. Okay, next. Now there's about 3 slides of these, it says up to 19, but there's also bonus questions as well, not on this slide. So these are the first 5, and I have looked for all the equations with the mass in them. Okay, so the first 5 here, you've got to fill in what is missing, what is underneath those, and you've also got the letters over here and the abbreviations over here for that equation to help as well. So again, I'm just going to give you, please use the sheets that I showed you at the beginning. Have a look through there, look for all the maths ones. Again, I'm going to give you a minute so that you can do that. And just write number 1 is this, 2 is this, 3 is that, and so on. Okay, you don't need to write out the equations. Okay, off you go. You've got 1 minute. You are halfway through, 30 seconds to go. Oh, my voice is going very uppy downy. It's a good job I'm not going to talk much tonight. Quite convenient. Nope. We are nearly on 10 seconds now. 10 seconds to go. There's 5, 3, 2, 1, and I think we're going to get a bit annoyed with that sound by the end of it, but anyway, doesn't matter. Right, so these are all the maths equations that I saw on there. Hopefully I haven't missed any. So number 1, sorry, my keyboard is not playing, it's wobbling everywhere. Let's move that back there, that's perfect. Right, so number 1, there I've got to click on it, is momentum. Okay, so the highlighted one is for the higher tier, so that's momentum. Number 2, acceleration, it's got the little A there. 3, weight, remember that unit for that is newtons. And then number 4 is density. It isn't a P symbol. I always forget what that Greek symbol is, but if anyone knows what that is, then please put it in the chat. And then the last one, kinetic energy. V is speed squared or velocity. Okay. I was going to have to keep drinking. So it is quite interesting. You know, if you've got a question on maths, you have to remember all the equations that have maths in it, and link up what the question has given you. What other details, what other data have you given? Right, that's going to tell me what equation to use. Okay, so it is worth familiarizing yourself with common things like maths, power and work done, things like that. Find out all the different ones that have those common ones in, okay, which we're actually going to have in the next couple of rounds. More physics equations. It's the same idea, right? Number 6 to 12. And this time we have a bonus question. Your bonus question is, what are the units for acceleration? This was not in that first round. So I wanted to make sure everyone was good with that. So again, I'm going to give you a minute, although there's more, but now you should get familiar with the equation. So I'm going to set you another minute and rest my voice so that I can speak by the end of the session. Off we go. Can you let me know if a minute is long enough, please? Someone in the chat, if you're happy with that, please let me know. If you need more time, please let me know. Okay. Oh, that was 30 seconds. This time I've included the abbreviations in these as well. Now you've got 5 seconds. Do you need more time? Or are we okay? Just in the chat, if you can put, or just say something if you need more time. Or are you okay? I don't get any message. I assume everybody is okay, which is good. It means that I'm giving you enough time. Okay. I think you just want to get to the Kahoots, don't you? Right. Okay, then. So answers. Oh, number 6 is your total energy. So useful over total. Number 7, wave speed is your V. Anything to do with speed is V. Density, mass divided by volume in this case, because we've got the capital V there. Acceleration, change in velocity. Now, number 9 is this one, V minus U. So that's your final minus your initial. Remember that, it's going to come up in another round. That is linked to also something in biology. So next one, power is your work done divided by time taken. And 11, what is force times distance? That's momentum, I got that on the brain. Moment of a force. And then number 12 is FD, so F for force, D. And then bonus units for acceleration. Please excuse the typo on this. It is meters per second squared. So if I can just correct that, it should be obviously meters per second, put the little squared at the top. I don't know how to do that typo on that for that, but yes, hopefully everyone was good with that. Okay, now this is my last physics one for this. As I said, there's about 20. There's another bonus question here. So this is the last round for revising your physics equations, and now I've chosen ones that are just a little bit more, I don't know, need a bit more detail, just that higher level stuff. Okay, so again, I'll give you a minute, and the bonus question is, what similarity can you see between elastic and kinetic equations? Okay, have a little think about that. The minute has started. Thirty seconds. Drink. Okay, 20. And we're on 10 seconds. And there we go. Right. I'm going to give you a few more seconds. I want some of you, please, see if you can answer the bonus question. Type it in the chat for me. Okay, what can you see? So whilst I'm going through the answers, some of you can do it to me personally or to the whole group, doesn't matter. Yeah, so I want to try and see some answers in the equations. So what was that, 13? Yeah, 13, number of turns in primary coil. Okay, and then 14 is the potential difference in the primary over the potential difference in the secondary coil. It's a new electricity one. 15 is your half times mass times a v squared, and elastic potential is your spring constant times extension squared. The elastic one you are given, but it's still good to know. Period is 1 divided by the frequency. Look, the answer's even there. And then 18 is your wave speed, equals frequency times wavelength, and then frequency times lambda. Right, we have 2. Yeah, I think both of you are spot on, but I think we need to combine it, basically. So one person has said there's 0.5 in both, and squared, and both have squared. Yes, this is my way. You are given, hang on, let me get that. Oh no, don't do that. You are given this equation. Okay, so when it comes to trying to remember the kinetic energy, obviously you're 11, you don't have to worry about this. Go to elastic potential and go, right, it is exactly the same as the two said. You have the 0.5 and a squared one. Look, it's still 0.5 times by something squared. Okay, it's the same format. Okay, this is pretty much the same equation, apart from you changed it to mass and speed. Okay, so what you'll also get if you have to work out kinetic energy, you probably have something in kilograms or grams in the question, and you might have something like that as well. So therefore you can go, well, it's just the elastic potential energy one, but I swap it for the mass and speed instead of spring constant and extension. It's just trying to, I'm trying to help you simplify your revision. My voice, this is not good. Oh, we'll keep going. Quick. We'll keep finishing this before my voice goes. Okay, so helpful hints there. Right. Something a little bit different. Again, as I said before, it is really good to know how many equations there are for like really common units, or really common measures, or what you want to call them. So power comes up quite a few times, 4 in fact, and work done as well comes up only twice, but anyway, doesn't matter. There's a reason why I've chosen work done, because I want you to list all the equations that have power in them and all the equations that have work done in them. And the bonus question this time, what is the similarity between work done and energy transferred? Okay, it might seem quite simple. It is quite simple, but away you go. Another minute. Oh, and I promise this is the last physics one. Okay. There's bound to be more rounds on physics because you've got lots of equations for physics. We have 30 seconds gone. Ten seconds. Near the bleepies. Turn off. Thank you. Right, let's see how you have done. Have you managed to find them all? I hope you have. I'm sure you have. And again, I've got to click on the slide before I go forward. That's fine. Right, so everything in red, basically. So we got power equals work done divided by time. Power equals energy transferred by time. And then you've got the electric ones, which is power equals current times potential difference. Power equals current squared times resistance. Okay. And then ones with work done in them, same as the power. Work done equals force times distance. And then power equals work done divided by time taken. So what I wanted to find out, I should have said I'll put it in the chat or something, but doesn't matter. What I want to share with you is actually these, can you see these two? Hang on, let me write. These two equations here. Oh, it's not, didn't write. Hang on. It's not writing, it should write. These two equations here are actually exactly the same. Work done and energy transferred is the same thing. The units are joules for both of them. Okay, they're just different words. It's just basically work done is basically how much effort, how much work have you done in terms of joules. Okay, so I just wanted to make that point. That's why I've kind of like done this round, just to make sure you're aware of it, and also to make you appreciate all the equations with a common factor, i.e. power, multiple equations for one thing. So you have to be aware of that, especially when you're trying to look for the equation. Don't just go for the first one, go, oh, look, it's got power in it, let's just do it. Again, as I repeat, you've got to look at the other bits of data, and then that will help you choose the equation that you need. Okay, brilliant. So there's reasons for my madness, trust me. Biology, yes, right, we're doing biology equations now. So find the sheet for the biology equations, please. The number in 1 to 7, that should be quite straightforward, but then I have added some bonus questions. Okay, so the first one is when you measure change, when something changes, is it final minus initial, or is it initial minus final? Okay, Remember, osmosis practical. And then number 2 is what units do you use when measuring the size of an image? So when you're using microscopes and things like that, magnification. Number 3 is what are the normal units you use when measuring distance or height? And the last one is complete the following. Okay, sketch it out quickly. It is your change of measuring units. Okay. If I carry on talking and then put it on for a minute, we will see how we go. If you need extra time, just shout in the chat. Okay, but I'm going to give you a minute. And we want to 30 seconds. Nearly done. Nearly at 10 seconds. And 10. If you need more time, just shout. I'm only doing 1 minute as a guideline, okay? Right, anyone needing more time? Are we all good? Excellent. So this should be quite straightforward because I literally copied it from there. But with biology, there's less really to sort of learn. Quite often they're given, but it is like basic maths ones as well that you've got to remember. So number 1 was size of the real object. Okay. Surface area is length times width. Surface area is like literally used every question, isn't it, really? That's the whole biology. If in doubt, just put increases surface area. That's volume, length times width times height. Percentage is your proportion over total. Some lovely basic maths. Percentage change. So I only put change here, which is why I did number 1 on the bonus bit. And then this is for separates, definitely, but light intensity, it was pretty much given this anyway, 1 divided by distance squared. And number 7, it's efficiency. Okay, efficiency is also used in chemistry as well, isn't it? So it's all to do with the smallest over the total and times by 100. Okay, so that's that one. So change for the bonus question. So let's put it over here. So number 1, it is always your final minus the initial. Okay, hopefully you got that one. When you are using or measuring images for magnification, you always measure in millimeters. Okay, which goes against the grain because number 3, when you normally measure distance or height or something, it is in meters. Okay, but obviously when you're using microscopes, it's going to be a bit silly, isn't it? Anyway, and then complete the following. So I've enlarged this a little bit. Sorry about the blurriness of it. But here we go. So when you are going, or when you're changing units to smaller units, you must multiply by 1,000 each time. That's why you measure in millimeters. Okay, you start measuring in centimeters, you've got to times it by 10 first, get to millimeters, and then 1,000. So it's always just in your head, go, right, I'm measuring in millimeters, then I only need to multiply by 1,000. And again, when you're going from small to big, oh, I've gone backwards. It is divide by 1,000. Okay, another little trick to the trade. And then obviously we should know that from our first round. Meters is M, millimeters is mm, and this is micrometers, and then nanometers is just nm. Okay, again, more units, and obviously changing of units there. Okay, chemistry. Okay, I think this is our last round. I can't remember now. I only just did this like this week, but this time all you need to do is match up the number to the correct equation. Okay, so there's a little bit more challenge because I muddled it all up. And also, one number has 2 letters. Okay, so again, I'm going to, oh yeah, please use the chemistry sheet this time. You've got that to hand. And the minute has started. So I'm just going to mute whilst I cough. We are on 30 seconds. Please let me know if you need more time. Well done. 3, 2, 1. Oh, dismiss. Thank you. How do we do? Are we doing all right? Need more time or not? Or should I just go straight to the answers? Okay, good. There we go. So 1 matches up with D. That is mainly for separates. Okay, so don't worry if you're like combined. That's normally a separate thing. 2 was E, so I've got here. 3 was G. It was number 4, the concentration, that has 2 equations that you can use. And then number 5 was B, and number 6 was A. Okay, these are your common equations that you have to remember for chemistry. Okay, all good for that one? I hope you enjoyed that one. Nice, quick and easy, simple ones. That was it. Yes, we're now on to rearranging. So I am going to now just refresh the old memory cells on how to rearrange. So you've got, I should really do the proper maths way, because at the end of the day, this is what you're taught. So if you need to rearrange, what you need to do is you need to make sure that whatever you're rearranging it to is the only thing on that side. So basically you've got to get rid of, like, for example, if you need to rearrange it for M, like they've done here, what you need to do is take away the A, and the only way to do that is to do the opposite to what is happening to it. So at the moment it's being times by, so if you divide each side by A, the A's will cancel out, and you'll get mass equals force divided by acceleration. Okay, if that is too much of a difficulty or stress, you can do it the triangle way. This is just one example. So we have weight here equals mass times gravity. My brain just went, it was G's, not grams. Gravity. So if you want mass on this side, you just cover up the M, and then it's W over your G. Okay, so there's that way of doing it. I will be testing you for equations with 3 things that multiply together. Okay, so please be aware of that. And then there's also the rearranging of the more complicated equations, like your kinetic and your elastic potential energy. Okay, so this is kind of how I would do it. I don't put or substitute the numbers in. I always rearrange the equation with the letters first. I find it far more easier and less messy, basically. So again, if we have to, we're making V the subject. So we are looking for this one here. So it is your bid mass. So what you've got to do first, you've got to get rid of fractions. So we need to get rid of the half. And the only way to get rid of a half is to multiply it by 2, like they've done here. Okay, so whatever you've got to do on both sides. So that will get rid of the half, but then make it 2e. You then got to separate those two, the mass times by the velocity squared. So to get rid of the m, like we did with the a, you divide both sides by m. Okay, but now we've got v squared. So we now have to square roots. The opposite of being squared is square rooted. Okay, so now we have our rearranged equation. Okay, so that is probably the most complicated rearranging that you will have to do with the making v the subject, or extension squared, or extension for elastic potential. Okay, so I thought I'd just go over that because you may need it. So the next round, this is the last round where we're going to just do loads of rearranging equations, not loads. Actually, I lie, we're not doing loads. So what I've got here, you won't need the worksheets with this. The equation is here. Please use your pen and paper to write it down. I've even written out the simplified version there, so if you want to just use that, then please do. So yeah, you just got to work out, rearrange it for force and rearrange it for potential difference. And I'm going to write the answers. And I'm not going to give you a minute because that is too greedy. No, it shouldn't. Well, if you need a minute, but I'm going to put 30 seconds on. There you go. And I'm also going to get quite hot. Ooh, 15 seconds to go. And if you've got the answer, can you write it in the chat? That's it. Ooh. Put your answers in the chat. Oh, let's see who has managed. Oh, hang on, who's, oh, you've done both. Thinking, what? Two different ones. Yeah, well done. Do it for both of them. So we have, how many we still got in there? I think we've got 7, that's fine. Brilliant, well done. And we'll go through these. We've got 2 people's answers. I'm just going to go through. So if we want force, we've got the triangle. I'm going to just put, oh no. I'll do the triangle first. To always excuse my triangles, they always go a bit wonky. So if you're not familiar with putting the equation into a triangle, have a look at what they've done. So here I always focus on that bit, where the 2 are. So then we can put force, and this line means divide, this one means times, divided by A, so it just goes there, and then you just put the last one in there, P. So we want force, so therefore it should be pressure times by area. Okay, so well done for those. And then potential difference, again I'll show you how to do the triangle because that's the easiest way. So again, I've got the Q charge times by potential difference, and therefore the last one goes at the top, which is your energy, and we want potential difference, so we cover that one up, and therefore it's energy divided by charge. Okay, so that's how I would do those. So next round, few more to do. This time you have one with 3 things to multiply as well, so I'm just trying to increase the complexity just a little bit. Okay, so you've got 3 here to do. I'm just going to put a time on for myself, and then once you've done them, try and put the answers in the chat, and we'll see how you will do. Made me jump, that did. Right, so that is 30 seconds. How are we doing? Has anyone done number 3 yet? And number 4? If you have, you can type it in the chat. Mm-hmm. Well done. Yep, I'm going to just start doing the triangles, my beautiful triangles. So I'm going to do current times your volts power, and then donk donk. Anybody stuck on the gravitational one? And then we do so that's your current squared times what resistance power. Okay, right, so let's do the number 3 and 4 first. So I've done the triangles. Again, with the question, when it comes up, do the triangle, put the, annotate, write it on the side so it will help you visualize. So what they want is current. So it's just your power divided by your volts. Resistance here, lots of resistance is power divided by your current squared. Okay, that's nice. Well done, people. Oh, I didn't realize it could do that. That's quite exciting. Well done. For this one, I'm not doing well with this today, am I? I'll make it just a little bit bigger. When you've got 3 at the bottom, when you've got this equation to do, the only thing that changes is you've got 3 things at the bottom. Okay, these are still times, that is still divide. So this is your GPE. Then you've got mass times gravity times your change in height. That symbol there just means change in whatever it is. Okay, so here I want mass, so I just cover up the mass. So therefore it will still be GPE and it will still be divided by, and it'll be gravity times by change in height. Okay, so well done those that got that. And then for height, cover up that one, and it's GPE divided by your mass times by gravity. Okay, so hopefully that explains how you would do that one. So don't ever get flummoxed with that one again. All you've got to do is just add another multiple box at the bottom. Okay, let's just check. Yeah, excellent. Well done those that answered. Beautiful. If there are any questions that come up, go through these and please let me know. Right, so I thought I'd end with the difficult ones. Okay, as you do. So I want you to find out what the mass is. Okay, I'm not going to tell you what equation it is. Got to work that one out as well. And extension. Okay, so we went through, the demo was about the extension angle, that and there's the mass. So again, this requires the multiple steps. So if you are, I have seen a question like this in combined, but definitely separates, you definitely need to know this. So have a little go. I will put 30 seconds on just to give you a little head start. Okay. There you go. 10 seconds. And dismiss. Right. Those who has done. Okay, I'm getting some answers through. That's good. It's hard to type it, isn't it? Yeah. Excellent. Thank you. Right, let me just get the pen. Oh, oh, sorry. Go down. What have you written? Excellent. Well done. There we go. Right, so if I write this out, you can double check your answers. So to get mass, I need your kinetic energy. So I'm just going to write it out fully because this is the way I can do it. 0.5 times your mass times your v squared, and also I like to use the letters, it's so much easier. So as in the demonstration, we have to get rid of the 0.5 first. So we have to times both sides by 2. So that gives us 2 lots of the kinetic energy equals the mass times velocity squared. Then we need to get rid of the v squared. So we need to divide both sides by v squared. So then it's 2 lots of the kinetic energy divided by v squared equals your mass. And that's your answer for the first one. The extension one, so that's this one here. So that, if I start over here, that's your elastic equals 0.5 times by your spring constant times by extension squared. Again, start with this one. So end up with 2 lots there equals your spring constant times your extension squared. And then we need to get rid of this. We divide both sides by that. Divided by the kinetic equals E squared. And then we need to get rid of the squared. So therefore, you square root. My voice is really bad now. And that is your answer. Okay. Again, just practice, practice. Well done. Root the whole thing. Yes. Brilliant. I think that was it. It is. So, have we got time for at least one Kahoot? Shall we try it out? Because I really want to try this out. Okay, so what I'm going to do, I'm going to stop. So we're going to share. Yes, yes. Really want to try. We've got a combined one, quiz, 11 questions. Is it that one? Oh, good try, but I have found some, so that's why I've shared them on the PowerPoint. Let's just go for this one. So all you need to be able to log into Kahoot. It was very easy to sign up. Are we all okay with Kahoot? If you don't want to carry on with this, and what I'll do, because this is very specific to the people here, I will stop the recording. And let me just go back to my PowerPoint first. I have given you lists of different Kahoots. That's my favourites at the moment. If it doesn't work, if the links don't work, please just message me, okay? And I can suggest some Kahoots for you to do, because obviously I've saved some. But I hope that has helped a lot of you. If you do want to stay on and do a Kahoot with me, brilliant. I'm up for doing that. But I will stop this for now, because obviously it's pointless having it recorded. But yeah, try the Kahoots. They're really good. A nice, fun way of also sort of keeping your brain active and trying to remember all the equations as well. But yeah, hope you've enjoyed it. Hope it's reminded you lots of units and equations and rearranging, and I hope it has really helped. And I will do another one again in the future. Okay, thank you. Bye.